All right, let's just look at this for a second. So it looks to me like we need to adjust longest, this guy right here, by some indentation amount. So how can we quantify how that indentation amount relates to our place in the tree? Because this one is not indented enough, and this one is extended too much. Okay, all right, here's an idea. If the longest is a sibling of us, then we are currently getting the correct length. That's what's going on here. This one is the sibling of this one, and this one are siblings of the winner. And their get item width is returning the correct amount. However, if our parent is the winner, that's what's going on with these guys, we are indented by one too many, so we need to subtract one indentation from the longest amount. Otherwise, we're going to extend past it, and that's what's currently happening here. These three guys right here are children of the winner, or they are children of a sibling of the winner. And they are extended, they are extended by one, which is not what we want. And then at the same time, if our child is the winner, that's what's going on here. This is the winner, this is the parent. Then we need to add one indentation to the longest amount in order for us to extend the correct distance. So right here, this guy needs to have one indentation added, and these three need to have one indentation subtracted. So can we generalize this algorithm based on where we are in the tree relative to the longest node? And what is that algorithm for finding the num indentation? So it's looking for me like, let's see, let me add a subtask to this. Okay, so this is a subtask, and it's looking to me like we need to subtract our indent from the longest and multiply that by the tree indent size, because this one is indented 2 times too many. This is indented one extra, and this one is indented 2 extra. So if we get the length of the longest and then subtract our indent, which is 2, from this indent here, then this will be 2 indents shorter, and it will line up. Okay, so the result of that math will be, might be positive or it might be negative. Like for this one, it's gonna add an indent to it, and for these guys, it's gonna subtract some amount of indent. Okay, so we're gonna need the longest indent. We're gonna need to get our tree indent finder thing back. So let's refactor that into a function. And let's just put that above our item, let's put that right here above our get longest name. We'll start there. So we'll do int find indent, value tree. And now we're gonna do auto node equals tree, auto root equals tree.getRoot. And then we'll do our auto indent equals, we'll do that tertiary thing. If the node equals the root, then it should have an indent of 1. Otherwise, no indent, something like that. Was that what it was? Maybe it was the other way around. I can't remember. We'll do, if the node is root, it's indented 1, otherwise, no, we'll do it the other way around. We'll try that. We'll see how that is. Okay, and then now we can recurse through it, or not recurse, we can just say if the node is not the root, then node equals node.getParent, and increment our indent, plus indent, and return indent. I think that's what it was before. I'm a little unsure about this line. We're gonna need more than just this information. We're gonna need not only the length, but we're also gonna need this indent. So let's just make it a struct altogether. So we'll do struct node info, and it'll have an int that holds the length and the indent amount, and it'll still have our value tree, so we can inspect. And now we got to update this function here to make use of this new struct. So we'll comment this out, and we'll just do node info as the return type, and put this here. And now let's update this. Okay, no more winner, node info winner, and this is gonna get changed. These two guys are gonna get changed. Let's see, winner dot length equals this line, and winner dot tree equals tree, and then winner.indent equals find indent tree. All right, that makes sense. Okay, so now we get to compare winner.length, not winner.first. If result.length is greater than winner.length, we can do that. Okay, that makes sense. All right, let's change this guy right here. Debug longest, and then make name longest.tree, so that we still get the same printout as before. Now, instead of returning longest.first, we can do our algorithm for num indentation. So we'll comment that out. Now we can do auto indent equals find indent tree. So we're getting our indent. If we pull this up, we're getting the indent of whichever node is currently having its item width figured out. And now we can compare that with, or not compare it, we can apply that difference to the longest one and return that. So we're going to do return longest.length, and we're going to add our difference now, longest.indent minus our indent multiplied by the tree view's indent amount. Winner view indent size. All right, let's check it out. Okay, cool, look at this. So they all have the same line except for the root one. So, okay, and we still have that leak, so we'll just kill this like manually. So let's, we'll remove that tertiary expression and just hard code that indent to 1. So comment this out, auto indent equals 1. Let's try this again. Oh, perfect, look at that, that's fantastic. And we get our horizontal scroll bar. That's the best. Okay, cool. All right, quit. Ah, we still have that leak. Okay.